Welcome back to the channel, guys. I'm back after some time off since I published my last video, which was the Axial flux motor. I had some work to do due to the uni and working on summer, but I had some time off camera to do some side projects, which I will show you in a second. Basically, what you are seeing is a tube notcher and a tubing bender, which I made at the start of this past summer. Basically, this notcher is a piece of, I think, 6mm thick plate with these two pieces of square bar with this hole bored to the exterior of the pipe. This fits very nice in there. Also this rotating plate with the two pillow block bearings and the hole saw attached at the end, and this angle protractor thing that I got very cheaply off AliExpress and actually worked pretty well. And also the tubing bender, which took me around 5 days to build. Basically it's manual, it's the ratcheting mechanism style, and both of these will have a dedicated video of how they work. Basically the same square bar thing as these ones. Basically I did the same, took double the length of this and chucked in the lathe, drilled and bored this hole to the exterior of the pipe, and then cut it in half to make this guide thing, and then the other half goes here to prevent to catch the tube and so it doesn't go out. Also I made all the pins on the lathe, these ones as well as these ones. This you can change from here to here, and then it's actuated by a 25mm solid bar here. I think the length is 1 meter. And the thing that took most time to do was the actual die, which you more or less can see how I made it. Basically 3 pieces of plate and made them round on the lathe. Basically the two outer ones are the same and the middle one is smaller in diameter, so I had welded this pipe sliced by half and then did all these slices to bend it all around the small disc. Then I made some spacers on the lathe and then started welding everything. You just pull the spin out, go back. Well, I have this. Here, you go back, and then you put the pin back in. And then you can go up to 180 degrees. Also, I made this degree scale. I need to print it again in PTG because some numbers fall off. Basically a piece of steel wire to use it as a needle so I can see how far I'm bending the tube. Here's a demo, a scrap piece that I bent and actually turned out really good. There's a bit of expansion, but nothing important here. And also did a 90 bend here, and actually it surprised me how easy was to do it. But yeah, I'm really happy how it turned out. I don't think I'm going to paint it. I like how it looks already, so maybe make a bronze bearing in here because there's a bit of play, but not so critical. Now this blue card, also the drift card, is hibernating. I need to get a new phone because I can't get the application working right, so I'm going to switch to a cheap newer one to see, because every time I start this I need to set all the parameters up, and I did that 2 times and I decided to screw that and put a better phone to be here as a dash. Actually this motor is 2.1 kilowatts, and this actually is going to replace the motor on the car alternator go-kart. Yes, I'm doing that because lately I was riding it with along with my cousins, and it doesn't run like when I fixed. So I decided to pull the trigger and I'm going to swap the alternator for this motor. I tried this, I connected it to the controller and runs perfectly. So the only thing I need to do is an adapting plate, remove the existing one that's on there, and make an adapting plate for this motor. So now here there's a bunch of stuff. This reduction motor, 24 volts, and made this piece to attach this 3-jaw chuck that I attempted to grind but I failed. So I use this as a rotary table for welding. This is a drill stand. Actually I changed almost everything here except this is broken, except this piece and the bottom piece. Everything else, this was a pipe. I replaced it with a solid bar and made all this contraption, which is a motor reducer with this kind of crank. So this metal rod goes up and down and has this interchangeable with this screw HSS square bit that I ground, so I can broach internal splines or keyways. Here's the test piece I did. Basically I mount this vise here, and then with the cross table I can go wider or do the spline deeper if I want, but I only used at the moment to broach internal keyways. I have these bearings as a spacer so this doesn't collide with the table, and I think I have everything plugged in. I know when I had it in the lathe it was running through, but now you can see that it's a bit wobbly, but it doesn't affect. There you have it. I add a bit of oil there. Basically, if I run this cutting tool this white, everything gets hot in a matter of minutes. So my plan is to make it half the width of this and then use the table to go wider. I also have this work in progress, which is a milling machine to work on the same drill press stand as the internal broaching tool. Basically here I'm going to add another bearing, exactly this one, and make a whole plate to attach here the bearing and the electric motor that will be that one. So also here, in a mess of wires, I remade the tool post milling attachment for the lathe. Basically, I made this new piece of plate on the CNC, put a bigger motor here, basically the same reduction, and I made a piece similar to this one to hold the angular contact bearings, so I can now drill and mill at the front and at the side. Basically, when I mount it, let's see if I can do it with one hand. I can mount it this way, or I can rotate the tool holder and then attach it here. And probably you're going to say, this is facing the opposite way, but if I remove the set screw, I can pull everything off, obviously outside the lathe, and then insert it from the other side and move the set screw to here, so the collet chuck faces that way. Here also I made this dividing head stand with this piece that when I tighten this bolt, this expands inside of the bore of the spindle here. So this way I can clamp this thing down here at the bench and then use it for indexing and to stop the spindle from the rotating, so I can do frontal milling or side milling with this. Also, like last week, I made this piece with the rotary head and actually came out really good. I need to remove this pattern, but actually this is going to be the output shaft of the axial flux motor that I need to chuck it in here, turn this down and turn this down a bit and face it so it's the same thickness as my model, as my 3D model. And here I have the two plates that will be the two discs of one on each side of the axial flux motor. Here I have these 10 plates to glue in here, and with the whole pattern that will be on here. So one plate will have the output shaft. Obviously I'm going to be making it in a way that you can bolt the output shaft on the plate you want. And also here I have all the dimensions of the shaft that joins one disc and the other. I will jump in to my other workshop and show you the progress I made so far with the axial flux motor. So here's all the progress so far I made on the axial flux motor. Here's the stator with all the coils made, and here I just made a test connecting the in and out of this coil and the other one that's on the rear to see how it looks. And I'm going to proceed to remove all the insulation of all wires and start wiring the full stator. By the way, here's the winding machine. I just got this for 30 bucks on Amazon. Coupled a DC motor here with a PWM, this one, and a foot pedal, potentiometer, and the stand. Here's a coupler I made on the lathe to mount to this M10 threaded rod to M4 with a threaded hole in here, so I can thread the coil core and start winding all the wire around here.